I want to show you some examples of concentration type solution problems. And the first one we're going to look at is number 3. This is from your assignment. What is the molarity of a solution of 0.650 moles of sodium hydroxide and 34.0 mils of water? So what we're looking for here is molarity. Now molarity is just another word for concentration. Our concentration covers lots of different units, but for molarity what we're talking about is moles per litre. So that's what we're looking for, moles per litre. We already have moles and we have milliliters, so I think it's fairly clear we're going to have to take the moles and somehow end up dividing it by the milliliters. Let's see how we would do that. For these kinds of problems, when we're dealing with just the one compound like we are in each of these, we don't really need to put the compound in the working. So we can just say 0.650 moles. And we need to divide by the milliliters. Now the way we're going to do that is multiply it by 1 over the volume. By multiplying by 1 over something, that's exactly the same as dividing by it. And we always like to keep the signs the same, so we'll keep it as times. So now at the moment what we've got is moles over milliliters or moles per milliliter. But we don't need moles per milliliter, we need moles per litre. So we're going to have to do a conversion here, and we know that 1000 mils equals 1 litre. So you can see the milliliters will cancel and we'll end up with moles per litre. This will give us 19.1 molar, or if you like, moles per litre. Either one of those units would be fine for that. Alright, so the important point here was that we had to multiply by 1 over the volume because we needed to divide by it. We knew we needed to divide by the volume because we want moles per litre in our final answer. This conversion here, we know that 1000 mils equals 1 litre, and any time we've got times in a line like this, whatever's on top and below the line have to equal each other. So times 1000 over 1 litre is the same as saying 1000 millilitres equals 1 litre. Alright, so that's for number 3. Let's take a look at number 4. What is the concentration of a solution of potassium iodide that has been prepared by adding 45 grams of potassium iodide to 237 mils of water? Well, again, we need a concentration, and concentration is moles per litre. We have grams, so I think that the first thing we should do is find moles. And that's generally a good rule of thumb. If you don't know where to go to moles first if you possibly can. And I'm going to have to convert that to moles using the molecular weight. And the molecular weight of this one is 166.0 grams. So that's going to cancel my grams. I'm going to be left with moles. So that's what I wanted first. I now also need moles per litre. So I'm going to multiply by 1 over 237 millilitres. And again, we need to do this conversion from milliliters to litres, so we end up with moles over litres, which is what we wanted. Remember, for this 1 here, in both of these instances, there's no unit next to it. And the reason for that is because we're just using it as a device to divide. So times 1 over something is just the same as dividing by it. And the 1 here now has no units. Now this is going to come out to be 1.1 molar. Just a note on significant figures here. We have 3 sig figs here, 3 sig figs here, so this came out to be 3 sig figs. We have 2 sig figs here, 4 sig figs here, 3 sig figs here, so this came out to be 2 sig figs. So it's always the smallest number of significant figures in the problem. Alright, so that's number 4. Let's take a look at number 5. How many grams of NaHCO3 are required to make up 15.0 mils of 0.250 molar solution of NaHCO3? Alright, so we know we need grams, which means that we really need moles. Now we know that concentration is equal to moles per litre. Stands to reason we can get moles by taking concentration and multiplying it by litres. In this problem we have a concentration which is 0.250 molar and we have a volume. So as you can see, to get moles we're going to multiply the concentration by the volume, so it really isn't going to matter which one of these we start with. We are going to use both pieces of information, but since we're multiplying them, or at least will be multiplying them, then there's no real need to worry about which one we start with. So I'm going to go ahead and start with the concentration. When I write the concentration, for the sake of dimensional analysis, I will expand the units out to moles over litres. So 0.250 moles per litre is what we're starting with. And what I'm going to do now is I'm just going to go ahead and multiply it by the volume. And the reason I'm multiplying it by the volume is because of what I've got up here. I know that concentration is moles per litre, so moles is concentration times litres. So there's your concentration. But this is not litres, it's millilitres. So now I'm going to have to do a conversion to get those to cancel. So I'll multiply it by 1 litre over 1,000 mils. I know how to arrange this because I want those millilitres to cancel. I also want the litres to cancel as well, and that's how I'm going to be left with my moles. Alright, so just in summary, what I did was I took the concentration, multiplied it by the volume in millilitres, and did a conversion from millilitres to litres so that I could get rid of that unit and just be left with moles. So at the moment we've got moles and we need grams, so I need to get to, I'll put 1 mole on the bottom and the number of grams will go on top, and that's the molecular weight, which is 84.01 grams. So as you can see, the moles will cancel now and we'll be left with grams. Alright, so that answer is going to come out to hopefully be 0.315 grams. Alright, let's take a look at number 6. What volume of water is required to prepare a 2.30 molar solution from 134.00 grams of FeCl3? Alright, so we need a volume. Now what you'll see here is we know that concentration is moles per litre. We could also say that litres then would be found by doing moles over concentration. Or, if you'd like, litres can also be found by saying moles times 1 over concentration. So that's going to be the basis of the way we're going to set this up. We know we need moles first, and here we've got grams. So what I'm going to do is I'm going to go ahead and get moles from that. That's 134.00 grams times 1 mole over the molecular weight of FeCl3, which is 162.2 grams. Or 0.12 grams. Now this will give us moles. Now we can go ahead and we need 1 over concentration. Now this is a little bit tricky because we've got 2.30 molar, which is 2.30 moles per litre. The other way of looking at this though, if we're taking the moles and dividing by the concentration, we're essentially multiplying by the inverse of this, which is 1 litre over 2.30 moles. Now remember that the fact that we've got a line here and we're doing the times indicates there's a relationship between these two. There's 2.30 moles in 1 litre, or 1 litre in 2.30 moles. Both of those mean the same thing. Now since we are multiplying by 1 over the concentration, that's why I flipped it and did times 1 litre over 2.30 moles. You can see the effect of this. We know that the moles had to go on the bottom to cancel, and we now have litres here, and the final answer would be 0.359 litres. Now you'll note that in the problem I was not told what unit to go to, so litres would be fine for that. If I did want to take it one step further, I could convert those litres to millilitres. And it'd be by multiplying 1000 mils per litre, which comes out to be 359 millilitres. Alright, so that's how those problems are handled.